Hi, in this video, we'll design a scalable and maintainable system for an online bird shop using advanced OOPS concept and design pattern. We'll focus on separation of concerns, dependency injection, and testability. We'll be using a repository pattern and factory pattern, ensuring the system is robust and adaptable to future changes. So first I'm going to add some dependency. So to construct this system, I'm going to be using Java 8, obviously, and I'm going to use JUnit, Jupyter version, and Mockito for my testing. So now that the dependency has been added, let's go to the program. I'm going to start off with by defining the core entity. So since I wanted to design a bird shop, like an online store where you can admin the bird online, like let's say that somebody wants to buy a bird from an online store, the initial design for that is going to start off with identifying the core identity and the core entity. So my core here is going to be bird. So I'm going to start with my bird class. My first class is going to be bird class. So this is going to represent the domain model and encapsulate the data and the behavior related to birds. So here I'm going to have two fields, which is ID and name. I'm creating the constructor to pass on these values. So this class is going to encapsulate the data and the behavior related to the birds. So I'm going to define ID and name for the birds that I'll be creating. And why this matters is a well-defined domain model is a foundation for a clean architecture. It ensures that the core business logic is decoupled from the infrastructure concerns. So here I'm going to now include the getter setup for this integer and the name using the generate from the ID, and let's choose int and ID and the name. So we have introduced our methods to get the name, set the name, and get the ID and set the ID. I'm going to save this class and let's focus on the next step. So the next step for us is going to define the abstract data access with the repository pattern. So for that, I'm going to create a bird repository. It's going to be an interface. So let's name it as bird repository. So basically to access the data access, we'll be using the repository pattern. This pattern will abstract the data layer, making it easier to switch the implementation without affecting your business logic. So for that, I'm creating an interface. So this interface is going to be the contract that will be defining the data access operation. I'm going to have three operations in this, which is going to be save, bird, void remove, and pass the bird in it. Then we'll also have find bird, so which is going to return bird type. So find by ID and pass into ID. So now that we have defined our contract for the repository pattern, which is bird repository, the next thing that has to be done is to implement this abstract data contract. So your contract is your bird repository. You're going to create the implementation for this repository. So for that, I'm going to create bird repository implementation, which is going to implement bird repository. So as soon as you add the implements keyword and the interface that it needs to implement, all the methods are going to pop in for you and you will have to define them now. For simplicity, I'm going to use list here to be adding and saving the flowers. I'm not really adding any database implementation. So to keep it simple, let's use the list from the collection list, and this should be accepting bird, and let's name it as birds. Add a list. So we have a save method. What our save method should be doing is it has to add the birds that are going to be passed to them. For the remove method, we will simply call the remove method supported by list, which is dot remove, and then you pass the birds inside. And for the find by method, we can use streams from Java 8. Here we'll have to return birds dot stream filter. In the filter method, you will have to call your lambda, which is going to be now your flower. Now your bird tends to lambda operator calling bird dot get ID, and this ID is equals to be the ID that you're passing from the method, and use the find first method or else null. So why does this matters to have this bird repository interface and then bird repository implementation is we are trying to promote the separation of concern one and making the system more testable and maintainable. So the abstract data access has been done, which is this is your abstract data access layer, and that has been implemented in the Bird repository implementation. The next step is to encapsulate your business logic in the service layer. So for your service layer, it has to encapsulate the core business logic and act as a bridge between your repository and the rest of the system. So for this, we'll be using constructor injection to inject the repository into service, ensuring loose coupling. For that, I'm going to create a class called service class. Let's name it as Bird Service. So your service layer is going to encapsulate your business logic between the rest of your system. Let's do that. So here we'll need our private final and Bird repository. Bird repository. Like I said, we will need a constructor which is going to be injecting the repository when the service is going to be called. So whenever we'll be calling the Bird service, the Bird repository is going to be injected. So we are going to encapsulate the repository methods such as save and remove, and let's do that here. I'm going to create a method called void add flower in my service layer, and in this I'll have to pass not flower, add bird. So bird and call the bird repository and save the bird. Next method that I'm going to be encapsulating was going to be public void delete bird and pass the bird repository, remove bird and pass the bird. Finally, public. This method should be returning the bird for us. This is find by method that is going to be encapsulated as get bird by ID. We'll have to pass ID for this and return repository dot find by and pass the ID. So your constructor injection ensures that the dependencies are explicit and makes the class easier to test in isolation. So now once this has been done, let's try to handle the object creation, and for that we'll be using factory pattern. So the idea is to have loose coupling, and we'll wanted to avoid tight coupling like creation of object logic throughout the application, and we'll be using factory pattern for this. And for that I'm going to create a class called bird factory. So the idea of our bird factory is to solely create the bird objects. Inside this I'm going to have a static create bird method which is going to take the ID and string name, and this would return as bird object. And next I'll be creating another factory class which is going to be bird service factory. Since we wanted to maintain the SRP, we are trying to create separate factories or separate classes for every responsibility that we wanted when we wanted to create objects. So the bird service factory is going to help us to create the bird service class objects. So let's do that as well. So this one is going to have a method which is a static method. Again, this is going to return as bird service. So let's keep it as create bird service. So for that we will need bird repository and a variable equals to new bird repository implementation. So this is our interface and a reference variable for the interface and the implementing class. And let's return the new bird service, which means the object which is going to handle its dependency here, where we are passing the bird repository dependency to our object, since we are also injecting them in the service class. If you look at it, our constructor here is getting injected with the interface, bird repository interface. So that has been handled in the bird service factory. So we have our entity class, we have our data repository interface and its implementation, and we have our service layer, which is our bird service, and we have isolated the object creation using factory pattern, which is bird factory class and your bird service factory class. Next, what we'll have to do is to create a test, which is bird service test class. The bird service test class will use a notation called mock from the Mockito. We'll need to call bird repository, name it as mock bird repository. And next, we'll need a bird service and a variable for that. Use our test ng before annotation and create a setup class, setup method, which is void setup. Call Mockito annotation and class and call the method open mocks, pass this to that. So next what we'll be doing is we'll be calling the bird service and pass the mock variable, which is your mock bird repository. So this is going to be your setup method for your test class, which is going to be called every time. So next let's try to add a couple of methods to test our methods that we have inside our bird service. First, I'm going to add a test annotation, and in that, I'm going to add void test add bird. So in this, what we'll do is we'll create a bird object using the factory methods. So I'm going to call bird factory and call the create bird, which is going to return as a bird object. So in this, I'll have to pass an ID and name. So my ID is going to be 1 and my bird name is going to be parrot. Next, let's call the bird service and call the add bird and pass this bird object inside. We have the verify method in the Mockito. Pass your mock repository, bird repository variable and all the save bird. So your first test has been added. Your second test is going to be for deleting. Void test delete bird. I'm gonna copy paste these things here and change my create bird method to take a different bird this time. This time the 2 is going to be crow and my add bird is going to be crow. So here I'm trying to add again. So but what we'll have to test here is deleting the bird. So we'll have to delete something that is already there. So in that case, I'm gonna reuse the bird that I already have and change my method here to delete bird and pass the bird, which is your. So I have my test delete bird method that I'm going to validate, and in this I'm again going to create some birds. And so instead of creating again, I'm going to copy paste the add bird method, and so here instead of add bird I'll be modifying it to delete bird, and you pass delete here, and as well as here you will have to change it to remove the bird. So my next test is going to be void test get bird by ID. So here the difference is going to be I'm creating the bird and I'm going to call the when annotation. So when the mock repository calls find by ID and pass your ID, then return bird. Import the static when method. Additionally, what we will do in the get bird by ID is we are going to validate the result returned by the mock and the service. And for this, I'm going to create another bird object which is going to be named as result, and for this I'm calling the bird service and try to get the bird by ID and pass 1. Here I wanted assert equals and pass my bird and the result, the one from the mock and one from the service. So the 3 methods that we have added into the bird service has been tested here. We can add a couple of negative methods. Let's add a test for invalid ID. So void test get bird by invalid ID is going to be my method name, and so use your when and your mock repository dot find by ID and call any int method, and when this is going to return null, in your bird object needs to be created, and this is going to be calling your bird service, and if your ID is going to be -1, you have to assert null result and verify your mock repository and find by -1. So if you look at your bird test unit class, we are trying to test the add method, delete method, get bird by ID, and I've also introduced one negative scenario to show the test coverage. And let's try to run the bird test service test. So we have our unit test also covered, and it has been done with the isolation from the other classes. We used our Mockito here, Mockito library here. So this is a simple demonstration of using dependency injection, repository pattern, factory pattern, and creating a system which is scalable and loosely coupled. Some of the trade-offs that we have done is using list as memory here, which is simple but not scalable for large data sets. A database-backed repository would be more appropriate for a production usage. And also, we have introduced our service factory and your bird factory. And the dependency injection that we have used in our service factory is okay for small system, but when you are going to handle with a larger system, you probably would wanted to use some Spring framework. So these two are the two trade-offs that we have done. So overall, the design was to demonstrate how to build a robust and maintainable system using advanced OOP concepts and design pattern by focusing on separation of concern, dependency injection, and testability. The system is both scalable and adaptable to future changes. Thanks for watching. Bye.